In the last previous class, we have discussed about the periodic classification. In that periodic classification, we have discussed about the complete periodic classification, how these elements are classified in different groups, how many periods are there, how many groups are there, and on what basis they have classified, on what basis these elements are arranged in the same group. That are all the things we have discussed. Along with that, we have discussed about the zero group elements also. Now, we'll start the remaining group of elements, that is a first group element, second group, and like that, so on. Particularly, we are discussing about the S block and the P block elements. Okay, now the first thing, the first group elements. First group elements, these are also called as 1A group. These first group elements, it belongs to the S block, right? See, in a periodic table, we are having 4 block elements, that is, this is okay. So this two it is called as an S block, this is D block, this is a P block, and this is F block. This is the first group, this is a second group, and this is third A, third B, 4A, like this. So now we are discussing about these S block element. Within this, we are discussing about the first group elements. This is also called as in first group elements or 1A group, right? 1A group, there is in first A group elements. In these elements, we are considering the elements like hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. One more thing here, you have to remember that the hydrogen, it is not considered under the first group element, but we are considering here because the thing is, as it is consisting of one electron, and this one electron, it is present in the outermost orbit. As you know, the hydrogen atomic number is 1 and its electronic configuration, it is written as 1. So that means 1s1, so that is, it is having one electron in the outermost orbit. So we have considered because of the same electronic configuration. The general electronic configuration of these elements is ns1, that is outermost orbit, it is consisting of one electron in the outermost orbit. For example, lithium if you take, that is an atomic number is 3, that is 1s2, 2s1, that means outermost it is having 1. For example, if you take sodium atomic number is 11, 1s2, 2s2, 2p6, 3s1. So here also 1. So the outermost orbit electronic configuration is 1. So commonly we'll call the electronic configuration of this first group elements, it is ns1. So the first group element, that is lithium, sodium, potassium, rubidium, cesium, and francium. Generally, the last element of almost all the groups in S block and the P block element, we are considering these are radioactive elements that we are going to discuss in a particular topic, radioactive series. Okay, now the general electronic configuration of these one, it is ns1. General electronic configuration of first group element, it is called ns1. These first group elements, they are called as an alkali metals. Why they are called as an alkali metals? Because most of these metals, if they are soluble in water, it is going to be form basic nature, so they are called as an alkali metals. So first group elements are called alkali metals. Metallic character, I told you in the periodic classification, the left side of the periodic table, it is all metals, it is having the more metallic character. From left to right, the metallic character is decreases. So that means the alkali metals are having the more metallic character. So at the same time, the metallic character, it is increases down the group. Metallic character is increases down the group due to increase in the size, right? So here down the group, the size is increasing, so metallic character is also increases. Metallic character is also increases. Basically, one best character, metallic character, we can say that it is having the donating capacity, right? Donating capacity, that it can donate its electron. So that is one of the metallic properties. So all the alkali metals, it is having the one electrons in the outermost orbit. So they can donate one electron easily in order to get the stability. So generally these are metals. So alkali, that is in first group element, they are called as in metals, particularly they are called as an alkali metal. So I told you that down the group, the metallic characteristic increases. So the cesium, it is having the more metallic character. The cesium, it is having the maximum metallic character in a complete periodic table, it is having a more metallic character. Now some of the constituent like cryogenic fuel, that it is consisting of liquid hydrogen and liquid oxygen, which is used in the rocket fuel. Oxyhydrogen or oxyacetylene, that is useful for welding purpose, gas welding at high temperature, that is 2400 degrees centigrade. This is degree centigrade. So generally these alkali metals are more reactive. These are very reactive, that even if you are going to be exposed in the outer atmosphere, if you are going to be keep, for example, sodium or potassium, if you keep open in the atmosphere, what will happen? It will react with the atmospheric oxygen, right, or the gases, it will catches the fire. Even if you keep in water, what will happen? It will catches the fire. These are highly reactive. So because of high reactivity, these are not going to be keep in the outer atmosphere or not stored in the water. Instead, these are going to be stored in kerosene or paraffin waxes, right? So this can be stored either in kerosene or in paraffin waxes. Paraffin waxes. Okay, where we can we can reduce the reactivity of these alkali metals. So these are more reactive. So because of the more reactive, these are not available free in nature. They are available in combined in nature, and these metals we cannot separate by the process called metallurgy, right? By simple roasting or simple calcination, all these things we cannot do this separation. There is a metal ores of these one, I mean to say the first group elements like potassium, sodium, all this cannot be separated simple electrolysis, because these are more reactive. These cannot be reduced. See, basically in the case of metallurgical process, we are doing the reduction process, actually reduction process to convert the oxides into metals. So we are doing the reduction process there. So basically these alkali metals are strong reducing agent. So these are strong reducing agent. These cannot be reduced further. Already these are strong reducing agent. How can we do reduction for this one? So these alkali metals cannot be done by the metallurgical reduction process. However, these can be separated only by electrolysis process. That means I want to say here, the extraction of these metal from its respective ore of alkali metals, these can be extracted only by the process called electrolysis. Okay, so these are more reactive and does not exist free in nature, right? Next, some of the compounds of these group, we are having the different types of compounds of these group. One is called baking soda, right? Baking soda, the formula is sodium bicarbonate or sodium hydrogen carbonate. This is NaHCO3, sodium bicarbonate or sodium hydrogen carbonate. Next, one more of this one. We'll see the importance of this one again. Next one is an caustic soda. Sodium hydroxide, it is called as an caustic soda. Sodium hydroxide, it is called caustic soda. Okay, then water glass, sodium hydroxide plus silicon, sodium hydroxide plus silicon dioxide or silicate, these are considered as an water gas. Washing soda, it is nothing but sodium carbonate decahydrate, that is sodium carbonate which is linked with the 10 water molecule, that is sodium carbonate decahydrate, that is called washing soda. Soda ash is nothing but sodium carbonate decahydrate, that is Na2CO3 dot 10H2O, it is called as in washing soda, and Na2CO3 it is called soda ash. One more thing, that is called as an hypo, which is used in the photography film. Now this hypo, the formula is Na2S2O3, it is called as a sodium thiosulfate. Chemical name of hypo is sodium thiosulfate. Chemical name of baking soda is sodium bicarbonate. Chemical name of caustic soda is sodium hydroxide. Water gas is sodium hydroxide plus silicate, that is in sodium hydroxide NaOH plus SiO2. Then washing soda is sodium carbonate decahydrate. Soda ash is sodium carbonate. Okay. Then hypo is sodium thiosulfate. Thio means sulfur group. Thio means sulfur. Okay. Next, borax sodium borate or borax sodium tetraborate. That means it is having the 4 boron. Tetra means 4, which is having the 4 boron, sodium tetraborate, and this is one kind of salt, and this is useful to remove the stains. Okay. This also we can discuss in the case of boron family, that is borax. It is concerned to the 13th group element. We can discuss there also. Okay. Then the rock salt or common salt or table salt, that is called as an NaCl. Common salt, what we are using in our daily life, that is called as an NaCl. It is also salts under compounds under group 1. Now, some more solutions, some more compounds of this one, that is brine solution. Brine solution, it is nothing but the common salt. It is a diluted solution of sodium chloride. Diluted solution of sodium chloride, it is called as an brine solution. And brine solution, it is useful for the preparation of different types of a compound like the sodium, sodium hydroxide, and so on. Saltpetre sodium nitrate. See, saltpetre sodium nitrate, it is saltpetre sodium nitrate. Same like potassium nitrate, KNO3. It is wrong, KNO3. Then sodium bromide, potassium bromide are used as a sedative. Sedative means which is reduces the tension. Sedative is one kind of drug which is going to be reduce your tension. Okay, so that it is consisting of sodium bromide or potassium bromide, and it reduces the weakness and it reduces the anxiety. I told you already that is washing soda is sodium carbonate decahydrate, and this can be prepared with the Solvay process, and this sodium carbonate is used in the soap industry and also a lab reagent. Sodium carbonate decahydrate, it is considered as a washing soda. It is prepared with the Solvay process. It is used in the soap industry and as a lab reagent. Some of the salts, again we are discussing about the salts, some applications of this one. Sodium chloride, I told you it is called as a common salt or table salt, rock salt, all this is a name. Diluted solution of sodium chloride, I told you this is called brine solution, right? Common salt and table salt. It is useful for the manufacturing of sodium hydroxide, sodium metal by the process of electrolysis, and this is useful for the preparation. The brine solution, it is useful for the preparation of sodium carbonate, hydrochloric acid, and chlorine. So these many preparations can be done from one salt, that is sodium chloride. From this sodium chloride, there is a brine solution. You will get sodium carbonate, chlorine, sodium hydroxide. Okay, right? Sodium chloride, it gives this many compounds, right? And it is also acts as in food preservatives, right? Generally, there is in some pickles, this we are going to be add the large quantities. Who are selling these pickles, they are going to be put a large quantities to store for long period. That is an sodium chloride. It acts as a good preservative also. Next, sodium hydroxide. It is called as an caustic soda. Caustic soda, sodium hydroxide, NaOH. This is a salt or the compound of the first group element. Okay, so it is useful for the manufacturing of paper, artificial silk, and textile, and it is also textile industry. It is also used in the petroleum refining and one of the lab reagent. Okay, and this sodium hydroxide, it is also useful for the preparation of soaps also. Soaps can be prepared, already I told you that is a soap. It is considered as a long chain fatty acid with the sodium or potassium. That is a fatty acid plus sodium hydroxide, it gives soap. Okay, so it is useful in the soap industry also. Next, sodium bicarbonate. Sodium bicarbonate, it is called baking soda. Baking soda, it is the formula for baking soda. It is in sodium, NaHCO3. It is used as an antiseptic. It is used for fire extinguisher, and it is in baking. It is useful for the manufacturing of baking powder. Baking powder is nothing but baking soda plus tartaric acid. Already we have discussed this one. Baking powder is nothing but baking soda plus tartaric acid. Okay, it is used as an antacid. Antacid means it is used to reduce the gastric content in our body. In our body, if you are going to take over food or some spicy food, the gases content it releases in our body. So to reduce this one, we can take baking soda, which is available in our daily life in our home. So very important thing, that is what are the importance of sodium and potassium. Sodium and potassium, it is very important in our body. That is, it is useful for nerve signaling. There is a transport, how the nerve signals, it is going to be transferred from one part of the body to another part of the body, because one of the reason, that is the sodium and potassium, it will maintain the nerve signaling. And it is also help for the transportation of sugar and amino acids into the cell. See, these are present in one is present outside, one is present inside, right? So they are maintaining an equilibrium. There is an the electron gradient, it is going to be maintained here. So this electron equilibrium, it is maintained by the sodium and potassium cells, and this will be helpful for the transportation of glucose, that is sugar, and amino acids, and the amino acids into the cell. And one more important thing, that is in potassium. Potassium, it is acts as a cofactor. Cofactor, it is an one which is increases the enzymatic activities. There is it acts as a potassium, it acts as a cofactor in the oxidation of glucose. The enzymes which are involving in the oxidation of glucose, this potassium acts as a cofactor. Then the next topic, that is called hydrogen. Hydrogen is, I told you this hydrogen actually it is not belongs to the first group element, but being it is having one electron in the outermost orbit, its electronic configuration is 1. So because of having the one electron in the outermost orbit, we are considering under first group element, but the position is not given. Okay, it is, we are considering it as in first group because of the electronic configuration is 1, but actually it is not considered, it is not given any particular place in a periodic table. It is kept separate. Hydrogen, it is kept separate in a periodic table. Why it is kept separate in a periodic table? Because it is showing the property, that is in hydrogen, it is having the properties, some properties which are related to the first group elements, and some properties are related to the 17th group elements. 17th group element, they are called as an halogens. Okay, so it is having some properties which are related to the halogen and which are related to the alkali metals. So these are related to alkali metals, right? So for example, we can take the first group property. I told you that it is having the one electron in the outermost orbit, and it will form a different types of a compounds, that what it is, how the sodium, for example, sodium, it will form with the ionic bond, it is going to form NaCl, that is, it is going to be combined with one. Hydrogen also, it is forming with the chlorine, it is forming only one chlorine, it is going to be combined. That means one sodium, it combines with one chlorine, one hydrogen, it is combining. So one of the properties is the same. In the case of the 17th group elements, as if you observe that any of these halogen, that is electronic configuration of this one, NS2 and NP5. That means any halogens, its electronic configuration, outermost electronic configuration of these halogen is NS2 and P5. So if it is accepts one electron, it will become stable. For example, chlorine atomic number is 17. Okay, 17 means 1s2, 2s2, 2p6. This is 10 is over, 3s2, 3p5. So 17. So that means if the chlorine accepts one electron, it will become stable. So chlorine, by accepting, it will become 18. So this may be common, then it is a 3p6. Right, so it will become, so if it is accepts one electron, it will become stable. Likewise, the hydrogen, it is having 1s1 configuration. So if it accepts one electron from any other atom, so what will happen? Its electronic configuration will be, hydrogen electronic configuration, it will become 1s2. So that means it will be showing some properties of the halogens and some properties of alkali metal, first group element. So as it is showing all the properties of the first group, I mean some of the properties of the first group element and the 17th group element, it is not being kept either in the 17th group element or in the first group element called alkali. So it is kept as a separate group and as a separate independent group. The hydrogen, it is discovered by Henry Cavendish. And hydrogen, we can consider it is a generator of water molecule. We know that the water molecule, it is consisting of hydrogen content, that is hydrogen and oxygen, it is mixed in the ratio of 1:8, and this hydrogen, it is a lighter gas. This can be easily separated by applying the high pressure and the low temperature. That hydrogen can be easily separated. I mean, we can separate the hydrogen from the gases. So this is a lighter gas. However, this is an somewhat explosive also, right? This is an explosive also. So we are not going to be fill up the gases, the balloons in this hydrogen. Generally, the balloons are filled with the helium gas, not with the hydrogen gas. So this is about the periodic classification. There is a first group elements, that is called alkali metals. Thank you. We'll continue.